So if we don't take the entire sine function, which stretches from like negative infinity all the way to positive infinity, if we just take a tiny little part of it, say this much, then we fix our problem, all right? We fix our problem of it not passing the horizontal line test, because if I just focus on this part and I draw my horizontal lines, it will definitely pass, which means I can find an inverse function for it, okay? Now, so what is the domain that we took? Well, we went from negative pi over 2 to pi over 2. We call this the restricted domain because that's all we did, is we just restricted the area where it lives, right? We just restricted the domain to negative pi over 2 to pi over 2. This is now called the restricted function, and it can have an inverse. So if the domain is from negative pi over 2 to pi over 2, we know that because it's a sine graph, the range is always negative 1 to 1, right? So for the sine of x, we restricted the domain from negative pi over 2 to pi over 2. This is the domain. And we said the range is negative 1 to 1, okay? Now, the inverse function is written as sine inverse of x. So let's recall, when we just had f of x and inverse f of x, how did that affect the domain and range? They swap, right? So for the sine inverse, the domain is going to be what? Negative 1 to 1. And the range is going to be negative pi over 2 to pi over 2, right? So we're just swapping domain and range, just like how we did it for all the other inverse functions. All right, so now finally, those smart people gave us this inverse sine function. Okay, now, you've seen this before? Well, I just showed you 2 seconds ago, so hopefully you saw that. All right, this is synonymous to sine inverse of x. So you can either say sine inverse, cosine inverse, or you can say arc sine, arc cosine. They mean the same in the world of trig, okay? The way it's read is y equals the inverse sine at x, and so on and so forth. So now, if I take the sine function and I invert it, this is what I have. This is the inverse sine function. It goes from a range of negative pi over 2 to pi over 2, and the domain is reversed. Okay, so what does all this mean? Okay, at the end of the day, what does all this mean? So far, we were looking for the values of the sine. So for example, if I told you, all right, you have an angle pi over 3, what is the sine of that? You know, you would do your whatever opposite and the hypotenuse and the horizontal and the vertical, and you got root 3 over 2. Now things have switched. Now we're going backwards. Now it's like a riddle. Now I tell you, all right, there is this mysterious angle theta. If you take the sine of it, it's root 3 over 2. Find me the angle. All right, so what's the angle? Pi over 3. Do you see what we're doing? So I have some angle theta. The sine of theta is root 3 over 2. And you have to find what that mysterious angle theta is. All right? And it's the same thing. You use your expertise on the unit circle. We're all experts now, right? If you're not an expert, you have, how many hours is it till Monday? That's how many hours you have, all right? Your test is on Monday. You can do it by Sunday, then you'll just be super prepared. 50 minutes? I have to be fair to the other class too. You guys are all my children. I don't know. Not during blackout. So many restrictions, like the restricted domain, right? Okay. Right. Okay, so here we go. We want an angle, okay, the sine of which is root 2 over 2. Okay, so I love that we now know that the root 2's belong to the pi over 4's and the 45's. Now, this is a positive root 2 over 2, right? So, pi over 4. All right, so between degrees and radian, we love radian. Okay, we meaning I love radian. So we're sticking with radian. Why? I know it's uncomfortable. This is the point. We got to get you comfortable until you go to calculus. Well, by then we will be in like chapter 8 and you will have no use for it anymore. Okay? All right. Now, here's a trick question. Sine of negative 2 pi. Well, okay. Why does it not exist? Okay, so the domain of the sine goes from negative 1 to 1, right? So whatever is in here must be between negative 1 and 1. Now, how much is negative 2 pi? Well, if pi is 3.14, then 2 pi is 6.28. That's way past 1. So this does not exist. There is no accepted terminology for this like there is for the domain. So whether you're right, does not exist, impossible, out of domain, no solution, all of them work.
The negative 1 to 1 based on the range of the inverse or the domain of the first one?
The domain of the sine or the domain of the inverse, the range of the regular sine. They're the same. Yeah.
Why can't the root 2 over 2 be 135, please?
It can't be 135 because we're restricted between negative pi over 2 to pi over 2, and 135 is in another quadrant. Right? So
you can't have like 3 pi over 4.
Right. Right. So we're restricted between negative pi over 2 to pi over 2. So we're in these two quadrants for the sine. We'll come back to this.
Oh, but for like the cosine around like the top 3 ball. Oh, yeah.
All right. Good, good, good. Okay. You will understand. He's remembering stuff from last year. All right. So for the cosine, we do the same thing. The normal cosine function has no way of passing the horizontal line test, but if I restrict this, again, just a loophole, right? If I restrict this between 0 and pi this time, why that and not something else? That's how, our ancestors thought it should be, all right? The math ancestors. So this is it. Now, when you flip it over, you get the inverse cosine, and for the inverse cosine, the domain is negative 1 to 1, and the range is 0 to pi. There is a nice chart or 2 charts afterwards, okay? All right, now, we want an angle, the cosine of which is 1. Okay? We want an angle, the cosine of which is 1.
0.
All right, so if we're confused, we can only get 1 or 0 for sine or cosine at the quadrants, right? And if cosine is the x-axis, then we're here, 1, 0. So the angle is 0 radian or 0 degrees. Okay, our cosine of negative root 3 over 2. Now watch, if we're going from 0 to pi, that means we're in either this or this quadrant. So in which of these is cosine negative? Quadrant number 2. So my angle has to live in quadrant number 2. All right? Okay, so we have root 3 over 2. Now if this is the cosine, it's the horizontal. So it's 30 degrees, which is pi over 3. And in here it's, okay, so it's 5 pi over 6. So we're the 30 degrees. Okay, look, we want the 30 degrees, which is the pi over 6's. 30 is smaller, so you divide by 6. Now, if I'm here, right, if I'm here, I'm just short of a pi. So that's 5 pi over 6, because 5 over 6 is just short of 1, okay? This is how, I know, there is always that remarkable moment when it clicks. I would have liked for that click to have been before the quiz, but we can take this too, yeah.
I don't have to click it.
Okay, it'll come. It'll come before Monday.
No. Honestly, I would rather. So why? I know I'm saying you're dividing by 6, but when it's root 3 over 2, isn't it a 60-degree inverse?
Right, but it's a cosine which faces the big side and the adjacent, which faces the small side, and the adjacent is root 3 over 2. Draw a triangle. Draw a triangle. For the 6's, right. So this is going to be 7 pi over 6. 7 pi over 6. This is 7 pi over 6 because it's 1 after. And this one is 1 under 2 pi, 11 pi over 6. 11 pi over 6. I will tomorrow. Okay. So here we have cosine of negative 2. Negative 2 is way out of my domain, so this doesn't exist. Okay? Out of domain. Now, tangent is a little bit simpler for once. I just take one of these arms or leaves, whatever you want to call it, right? It's pretty much already like figured out for me. Now, if the range of this was all real numbers, what's happening here? The domain is going to be all reals there, right? Yeah. So domain is negative to positive infinity, and the range is negative 1 to 1. But remember, we have asymptotes, so they're open parentheses, not closed brackets. All right? Remember this, yes? All right. Now, inverse tangent of 1. Where is tangent 1? Okay, so it's the pi over 4s. Okay, so this is the next click that we have to come to. Okay, one more time. Tangent compares the two. Okay, tangent compares the two legs. If the comparison is 1, that means the two legs are equal. That only happens in an isosceles 45, 45, 90. Okay? That's when tangent is 1. So this is pi over 4. Okay? So this one, yeah. Just take the positive. I'll talk about that later. Yes. It can't be anything else. All right? Arctan of root 3 over 3. How about we draw a triangle for this one? Well, for this one time, okay?
This one's the 1/2 over root 3 over 2.
Right? So this is, look, 30 degrees gets the 1/2. This gets the root 3 over 2. Arctan is pi over, okay, so how are we going to, pi over 6. All right.
Wait, what? Why is pi
Wait a minute, wait. It's pi over 3. Pi over 3. Pi over 3. We're getting there. Okay. No. No. Okay. Okay, let me, guys. Okay, let me have your attention. Look, we drew this triangle. 30 is the small one. It gets the half. 60 gets this. Now, we want tangent, which means what?
Sine over cos.
This over this. The opposite over the adjacent, right? So it's that. I'll come back to this. I will come back to this, yeah.
For A, why can't it be like 5 pi over 4? Like in between negative pi over 2 and pi over 2?
Because of this. So look, this is the one I'm going to skip. I'm going to skip the graphs, okay? They're really easier than you think, but we will come back to this after the test. They won't be on the test, but they will be on the final. Look, this is a chart. Hey, I'll take your question in a minute. This is a chart that's not from your book. A long time ago, I used to teach Trig just as a course on its own. And this is from the book that I used to use for that. I love this because it gives you, for each inverse function, the domain, the range, and the quadrants in the unit circle where it must exist. So for the inverse tangent, it can only exist in quadrants 1 and 4. Okay? No, you start here and you go there, this way. Okay? It's quadrants 1 and 4.
So we're never using the unlike quadrant?
No, not for this. Okay?
The inverse
We're asked for the negative, the inverse tan of, inverse tan of 1, negative pi over 4 would still work instead of the quadrant. Why shouldn't that be?
Negative pi over 4.
For the inverse tan of x, negative pi over 4 and pi over 4.
You can take both. Yes, you can take both. Yes.
It says the inverse tangent function is restricted to the domain negative pi over 2 pi over 2.
Mm-hmm.
Then this drawing, it doesn't have a domain restriction, it just has a domain restriction.
Well, that's the range.
No.
Interval is the-
The negative pi over 2 to pi over 2 of the regular tangent function
Oh, because, no,
then becomes the domain of that.
yeah, but it's like a typo, I guess. It's-
I'll take a look at it. Let me see.
It says the inverse tangent function is restricted to this domain, but it's
Right,
not.
so it's from here, from this domain, we take the inverse tangent, which then becomes that.
Right, but this isn't the domain restriction.
No, that's
That's
the
the
domain
domain
restriction.
restriction of the regular tangent,
This
which
is
then
the-
becomes the inverse tangent. Range.
You're confusing the regular tangent and
Right,
negative
but
tangent. Well,
that would, this would be, this says the inverse. Is that?
Okay,
Oh, yeah, this would be right.
okay, I'll fix it.
It's a typo there.
Yeah, that's why.
Okay.
I thought.
Wait, I don't understand why it would be negative pi over 4 also, because when it isn't tangent in
Okay, so look at this stuff. Let's go to these couple problems. Okay, so what we want to do here, these are the basic ones, right? Where you have sine and arcsine, one cancels the other out. Okay, so it's just a half. Same thing with this. So it's just negative 5 pi over 2. Perhaps. Okay, so watch. For this one, what you want to do is start from the inside, right? We always start from the inside and work outwards. For this, you want to draw a triangle. Okay? This is theta. Now, what this is saying is there is an angle theta, the cosine of which is 4 over 5. Now, cosine is adjacent over hypotenuse, right? So this is 4 over 5. Okay? Now, I want to find x here. How much is x? 3. The second step is then find the sine of this angle theta. Okay? Right. So now sine of theta is 3 over 5. It's always the same process. Start from the inside, draw a triangle, then do the outer function. Okay? Now, you're not always going to have cute little numbers in there. You're going to have x's. Okay? This says there is an angle, the sine of which is what? X. Okay, so x is really x over 1, which means the opposite over the hypotenuse is x over 1. So if this is theta, the opposite over the hypotenuse is x over 1. Can I find this missing side? How? What would it be? Right. So this unknown is x squared plus something squared equals 1 squared. So this is the square root of 1 squared minus x squared. Okay? Are we all okay with this?
Wait.
Opposite.
The same
Okay.
thing.
X squared plus this squared equals 1 squared. for the first one, I will put in 1 squared, but never again, right? It's just the 1. Now, if I want to find the cosine of this angle, cosine of theta is adjacent 1 minus x squared over x. That's it.
Wait,
That
wait, isn't it wrong?
over 1. This is it if your denominator does not have a root. If the denominator has a root, what do you do? You have to rationalize it. What's the term for it? Rationalize it. Okay, so do this next one. Draw a triangle for the x. Find tangent. Don't call out the answer. This time, cosine is x over 1, so this is what? Right? Right.
So that's the same thing every time. It's the same triangle every time. If it's just x.
Right, but depending on, like, if you had tangent, you know, the configuration might be different if you had tangent or cosecant, but it's the same triangle. Hey, that's a good idea. Now I gotta go back and rewrite the test.
What are John saying?
What did he say?
He said, are you gonna put like 2x or x?
All right.
Plus 2?
The test is done. It is written, it's done, it's done.
So we don't have to beat him up after?
No. No, we're still gonna,
I'm sure she thought of that.
okay, here. So, you're in a movie theater.
Oh.
There is a 32-foot tall screen. Listen. There's a 32-foot tall screen located 8 feet above the ground. You want to write a function modeling the viewing angle for a person in the theater whose eye level when sitting is 4 feet above the ground. Okay, so they have a diagram for you here. Okay, so this is his eye level. His viewing angle is this. It's the dashed lines. So basically it's from the top of the screen to the bottom of the screen. Okay? Now, we're going to divide and conquer this. We're going to do it in parts. We have the distance d. Okay? We're going to use d for the distance. The screen itself is 32 feet and it's 8 feet above the ground. He's 4 feet above the ground. All right, so what we're going to do is, I'm going to write an expression for theta 2, which is this entire thing. Then write an expression for theta 1, or do it in the reverse order. And what should I do to those two in order to get the one in the dashed line? Subtract them. Right. So, for theta 1, that's this tiny little sliver there. The horizontal distance is d, and how big is that distance there? Well, this little one is 4 feet. So this is opposite and adjacent, meaning tangent of theta 1 is 4 over d. Okay? So, no, we don't need to find d. So what's theta 1? It's inverse tangent 4 over d. Right? And we're going to leave it like this. So guess what? Out in the real world, you're not going to have numbers to substitute every single time. Sometimes, you know what, your answers are just going to have more variables in there. That's fine, okay? All right, for theta 2, right, again we have tangent, but this time it's what over what?
36.
Right, so we have 32 plus that balance of the 4, right? That's 36 over d. 36 over d, so theta 2 is inverse tangent 36 over d. All right, theta then, theta is theta 1, theta 2 minus theta 1. So we have inverse tangent 36 over d minus what? Inverse tangent 4 over d. Okay? So this is a model for the viewing angle. So the next time, right, you're at the theater, all you have to do, measure the distance there and the height, and we're good, right? You can figure out the space where you need to sit to get the maximum viewing angle. However, you also need your graphing calculator with you, okay? Because that's what we're going to do here. Determine the distance that corresponds to the maximum viewing angle. This is what? This is one of those, you know, optimization problems that we used to solve back in the day, remember? So we're going to plug the function for theta into our y here. And it just so happens I already have it in here. So inverse tangent 36 over x minus inverse tangent 4 over x. Now, theta is your y over here, right? D, the distance, is x. So think about a logical window for this. First of all, do zoom 7 so you're in trig mode. And then, for the window, I want you to do for the x min and x max 0 and 65. So x is the distance, right? So figure 65 feet, okay? It's of course, like there is some trial and error. So go 0 to 65 and then press zoom fit. Remember what zoom fit did? Right. So zoom fit, it's this one, the 10th options or 0. And if you press enter, what it does is it adjusts the y scale so that it shows you the entirety of the graph over the x values that you've specified. Does that make sense? You can see this. So just go from 0 to 65 and then press zoom fit, zoom 0. Okay? Yeah, it's amazing. Like, you have no idea how much of a thrill this is for me. I'm hiding it because then I would just be bouncing off the walls. But it's amazing. All right? So now, if this is like, by the way, I thank the English teachers of the world, because if it wasn't for them, I wouldn't have this here, the stool, which I use as my book rest. So thank you for the English department. So look. When the distance is maximized, this is where theta is maximum, right? So we have to find that. That's, if you sit right there, that's when you get your maximum viewing angle. Before or after that, you're going to get a smaller viewing angle. So second calc, maximum for, it does. Did you, let me see. Did you graph it correctly? Did you put the function in there correctly? So here, this is the left bound. And then we're going to pass that for the right bound. And here we go. So if you're sitting 12 feet away, you get a maximum viewing angle, which happens to be that many radian, which we're not concerned about right now. So, maximum viewing angle when, so the seat is, what is it, 12, what's the unit? Feet. If you don't put the units, you did all this for nothing, because are you sitting 12 centimeters away? Are you sitting 12 miles away? Right? Makes a difference, okay? 12 feet from the screen. Hey. Okay, so that's when you get your maximum viewing angle. So the next time you go to the movie theater, make sure you ask the specifications of the screen, how high it is. But see, now they threw in a wrench because, well, no, now the screens are more like panoramic. However, after we do chapter 8 or 9, which is about polar coordinates, You'll be all set.
Right.
That's it.
So can't wait to get the real
Yeah. Yeah.
right now.
If they ask for the maximum volume, would you say 53 degrees?
If it asks you for that, yes.
Oh, you say.
Okay,